We are live. Woohoo! This is Math 60, Intermediate Algebra, and this is 2.3, and things are getting very exciting. We're going to talk about rate of change and the slope of a line. This is it. This is the concept that eventually goes on to build the basic foundation of calculus. So this is the big time right now. Very exciting. So what the heck is rate of change? Well, rate of change, rate means how fast of change. So how fast is this thing changing? And the way we define this in math is we take the total change. So how much change has happened? Did you run a mile? Did you run 10 miles? Did you run 100 miles? Yes, I have friends who do that. I myself do not. I teach math. That's my superpower. So the total change divided by the amount of time. So if I told you I ran a mile in 6 minutes, that's impressive. If I run a mile, same distance, in 10 hours, you'd say, well, yes, you still ran a mile, but it's a different amount of time, so you weren't going as fast. 60 miles an hour is different than 60 miles a minute. So this is what we're going to be looking at, rate of change. So we're going to start off with Star Trek. Of course we are. At 4 p.m., there were 20 tribbles in the grain bin. Tribbles. Tribbles are little, a tribble is a little animal that looks like a furry sponge. They're not orange really, but I don't have brown. So it's a little animal. It's a pretend animal. And they like to eat and they like to have lots of babies. That's what tribbles do. So at 4 p.m., there were 20 of these things. By 6 p.m., there were 35. What's the rate of change of tribbles in this example in tribbles per hour? Now, this is really, really the important part of the question. And time again, I'm going to tell you that when you're looking at word problems, what you want to do is you want to look for the last part of the word problem. Usually the very end of the word problem will tell you what's important. Fun fact, usually the very end of the trailer for a movie tells you how the movie ends, right? Same thing. The very end of the word problem tells you what you need to know. So the word per means divided by. So we're going to put tribbles on top and per, here's the per right there, and then hours on the bottom. Now, you could write tribbles per hours like that. I think a lot of people would feel more comfortable if you wrote number, the number of tribbles over the number of hours. So tribbles per hour, this is what I'm interested in. Let's look at the rate of change, the total change. So how many, not just how many tribbles were there, but what was the change? So I'm going to write change in the number of tribbles. Okay, so I want to know the change in the number of tribbles over how long did it take. So up top, we went from 20 to 35. So up top, the change in the number of tribbles was 15. I don't write 35, I don't write 20, I write 15. That's how many new tribbles there were. And then the number of hours, I can't really do the subtraction here. I can a little bit, but it's time. So time gets tricky. Be very careful. 6 p.m., 4 p.m. So, oops. 6 minus 4 is 2 hours, right? From 4 p.m. to 6 p.m. In 2 hours, there were an additional 15 tribbles, which is approximately, or actually exactly, although I don't think you can have half a tribble, 7.5 tribbles. I know it's a funny word, per hour. Now, obviously, when we look at the rate of change, we sometimes get numbers that don't make sense. You can't have half a tribble. Tribbles are animals. They're either there or they're not there. So this is an average. Between 4 and 6, there were an extra 15. Did they come out exactly 7.5 tribbles per hour? No. They probably came out at different rates. So a couple, and then not for a while, and then a couple more. So when we do the average, we'll get a funny answer like this. We've got to just take it as an average. This is an average. Average rate of change. It will take us a couple years. It'll take you a couple years to study to get to the point where you can start talking about something slightly different called the instantaneous rate of change. That's a little different, and that's in calculus. Right now, we're just going to look at averages. Now, as a fun fact, I wanted to look at how this converts to per minute. So if I want the change in the number of tribbles per, again, per divided by the number of minutes, how do I do that? Well, I could do a couple things. One thing is I could say 2 hours right there is 120 minutes. Bam, you could do it that way. I want to show you a slightly different way to do it. You ready? Take a deep breath. You may need a support animal. I'm going to bring in Godzilla. Godzilla is always there for us. Here's Godzilla. Again, I'll remind you, Godzilla, the ultimate loving, maternal, character. Sure, she was willing to destroy Tokyo, but it was because she loved the earth. Okay, so she wasn't the monster. She was just misunderstood. I wish right now I had a Mothra puppet. I would totally use my Mothra puppet. So I gotta work on that. And the turtle that went around in circles. I can't remember his name. You probably are screaming it at the screen. Either that or you're saying, what is even happening? Math just went, wah. Okay, I'm bringing it back in. So if I want to know the change in the number of tribbles per minute, let me show you something. If I know the change in the number of tribbles per hour, now you're going to look at this and go, no, those two are not equal. Those are different. And I'm going to say, yes, you're right. They're different. But then what if I take the number of hours over the number of minutes? And then, where's my red pen? Notice what happens. The hours cancel out, and we get the changes the number of triples per the number of minutes. Now, this is something different. I believe this is not in the book. However, for those of you going on to chemistry, this is just a preview. This has to do with, this is called doing algebra with units, basically. So if I want to convert from per hours to per minutes, I have to put in this little conversion factor. So what was the change in the number of triples per hour? It was 7.5 times, now the number of hours per the number of minutes, let's see, that was 1 hour for every 60 minutes. Okay, this is getting ugly. 7.5 times 1 over 60 is going to be, well, 7.5 over 60, which is equal to, where's my calculator? This is not the most elegant way to do it, but it is a way to do it. 7.5 divided by 60 equals 0.125 tribble per minute. So in other words, every minute we get about 1/10 of a tribble. So every 10 minutes, we're going to end up with a tribble. Kind of woohoo, kind of weird. So first page, lots of fractions, lots of Star Trek. Life is good. Second page, let's move it into math land now. I want to talk about a particular kind of rate of change called the slope of a line. Now, again, I am not teaching you slope for the first time, I hope. I hope that you have taken algebra before, and so you've had an introduction to slope. If not, I recommend that you go and look on YouTube and find my other videos for Algebra 1 or Math 40 for talking about slopes so that you can brush up. Because this is not going to be an introduction. This is going to be more of a review. So I'm going to just start right off the bat with all the formulas. So here we go. You guys ready? Get yourselves a nice yummy drink, some snacks. The support animal, slope, which is just like the English word slope, like the slope of a mountain. There are steep mountains and there are not so steep mountains. We use the letter M to represent slope. And it is frequently, people remember it as the rise over the run. This is one way people remember how to do it. Basically, it is the change in Y over the change in X. And here you'll see I said this character, this is a Greek letter, delta. It means change. Delta Y over delta X means change in Y over change in X. And the formula that you've probably memorized, y2 minus y1 all over x2 minus x1. This is all awesome. And in a perfect world, you will memorize all of this. If you are going on to calculus, you will tattoo this to the inside of your eyeballs or just memorize it, which seems like it's much more hygienic and less painful. But what I want to do is I want to step back a little bit and say, yes, that's fine. And this is all true and mathy. But what do slopes mean? So what does it mean to have a positive slope? Well, we decided, and this has to do with the fact that when we read English, Latin, late Greek, French, German, bunch of other languages, not all languages though, but a bunch of languages that were being used to develop some of the concepts of algebra that we inherited here. Again, not the only maths in the world, just the ones that we are learning about here, came from folks who were reading from left to right. And so we also read graphs from left to right, just like we read the language, Latin, late Greek, etc. And so a positive slope describes a line or a line segment that heads upward when you go from left to right. It goes up. And it can do so very, very steeply. And it can do so very, very shallowly. Shallowly? That's a weird word to use. But basically, as you go from left to right, you end up heading upwards in the Y direction. Okay, so what is a negative slope? Well, a negative slope, in the same way, if you go from left to right, you end up heading down. So this means that this is a line that's headed downward, or a line segment. And again, it can be very steep or it can be very, very shallow. So this is a way of describing a line or a line segment or ray, describing whether it heads upwards or downwards. What does it mean to have a zero slope? It means you don't go up and you don't go down. So in other words, oh, that's terrible, but slope equals 0 is flat. It heads in both directions. It doesn't go up, it doesn't go down, it's just flat. Tell me about a horizontal line. Well, a horizontal line Slope equals 0. Woohoo! This is going pretty well. I'm feeling pretty good about these. Next up, what about a vertical line? And here's where the problem comes in. If I could, I would scratch a record, except I don't want to scratch any of my records. I love them. They're precious. But so, vertical lines. Change in y over the change in x. Let's look here. A horizontal line, the change in y over the change in x. This is 0 over whatever this change is. Doesn't matter when you look at the two values over something, which equals 0. 0 over something that's not 0. What's the problem here? Well, if I look at delta y, the change up and down, versus delta x, the change left to right. So this is the left to right one. This is the up and down one. We get something over, how far left and right do we go? We don't go at all. 0. Oh no, oops. Oh no, undefined. So we say a vertical line has an undefined slope because we can't describe this with a fraction because the denominator is going to be 0. So if it's flat, lovely. Slope is 0. It's awesome. Vertical line, it's still a line, but we cannot describe its slope using real numbers. In fact, we cannot describe its slope right now at all. We just say the slope is undefined. It's a vertical line. Okay, so having said that, dun dun dun. So, and this is the exciting part because I'm going to do this live on camera, except I won't be live for you unless you're watching right now. But let's see. I'm going to draw this line. And then I'm going to draw this line. So I've just drawn 2 lines. And I'm asking you to find the slope of these lines. Now, to be honest, I'm going to tell you something. The caveat is that it is impossible to look at a graph and know exactly what the graph is saying. Because the thing is like, for example, these 2 lines look like they're going through this point. First off, there's no scale. So I have not told you what the scale is, so we can't know for sure. It kind of looks to me to be the value, and I will tell you this will be x and this will be y, because that's the way we're going to do it in this class. But kind of looks like x equals 1, but maybe x is 0.993, and you wouldn't know. It would look just like 1. So whenever we're looking at graphs and deciding what's going on, it's a guess, right? It's an estimation. We're getting close. So we got 2 different slopes to look at. We've got the pink slope, the pink line. And we've got the green line. And I want to talk about how to find or how to approximate the slopes. So the first step is going to be finding some points. And I'm going to find, I think this is at the point 1, 0. I drew these, so I'm going to say yes. In fact, this is the point 1, 0. And in fact, I'm going to tell you that this point is the point -1, 2. And I'm also going to tell you that this point is the point 1, 2, 3, 4, 5. This is the point 5, 2. So I'm going to give you those values. So if you're asked to find the slope of a line, and it's a graph, what you want to do is you want to find the points that the line passes through. So the pink line passes through the points -1, 2, and 1, 0. And the green line passes through 1, 0, and 5, 2. So here's the thing. You've got two options. The first option is to use the formula. And I'll remind you of the formula. Hopefully you've seen this before. If not, if this is the first time, then this is the formula. What you want to do is you want to take y2 minus y1. So take the difference in the y's over x2 minus x1. Now, you're going to ask me, which one's y2 and which one's y1? And the answer is it doesn't matter. What this is telling you is whichever one you start with on top, you have to start with on the bottom. So let's see. Let me start with this one. I'm going to do this y minus that y. And then I'm going to do this x minus the other x. And let's see, I got 2 over -2, which is -1. So the pink line has a slope of -1. Okay, that's nice. That's great. Life is good. Let's look at the green line. Again, I've got these 2 points. Slope is y2 minus y1 all over x2 minus x1. Okay, again, I got to pick one of these to be 2. I'm going to pick this one to be 2 because it's bigger. So I'm going to do 2 minus 0, 2 minus 0, which difference in the y's. And then I'm going to take the difference in the x's. I have to start with the matching guy there, 5 minus 1. Let's see, this is 2 all over 4, so that's 1/2. Notice this is a negative, which makes sense because the pink line is heading down, so it's negative. This one's positive, it's heading up. And in fact, can you see that this is a little more shallow and this is pretty steep, whereas this one's kind of shallow. Okay, so that's lovely. And, we're getting in towards, what should be the end of the video. And yet I want to show you something else. If we go to the graph, and I want to start with the green line, if we go to the graph and I see this point and this point, I'm going to take a little walk. Walk, 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 walk. And I'm going to go up. So basically, I made what is called a right triangle. I drew a triangle from this point to that point. I made that little triangle there. Now I'm going to count this. 1, 2, 3, 4. So this side is 4, and this side is 2. And for the green line, rise over run. So the rise, it went up 2. It went to the right 4. So that's 1/2. So by drawing this triangle here, this triangle right there, I got exactly the same work that I got here, but without this formula. Now, here's the thing. If you're going on to calculus, if you have to go to trig or calculus, if you have to go on to another difficult math class, you should have this memorized because this is necessary. If this is your last math class, or the next math class you need to take is not going to be a difficult algebra math class, or if, for example, you're going into another field, and you can always talk to me about this, then maybe you don't need to know this. Maybe you can use the triangles method. So it's an option. You can keep them in your pocket together. They'll totally get along. Okay, let's look at what the pink one looks like. So for the pink one, if I go walking, da, 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 da. I walk to the right, and then again, this time I have to go with my pink triangle. Let me draw it right here. I drew it the wrong way. Never mind, don't let me draw it that way. My pink triangle, I move over, I walk to the right 2 units, and then I walk down another 2 units. So this is 2 going this way, and then it's 2 going down. So for the pink line, the rise over the run is basically 2 over 2, except we went down, right? We had it down instead of up, so that's negative. So we have to consider it a negative slope, just -1, which is what we got here. Now notice that when we did the math, we ended up with the minus on the bottom, and when I did the triangle, I did the minus on the top. As long as there's the same number of minuses, you're golden. Doesn't matter whether it's top or bottom. So we've got 2 options. One is going to be using the graph and drawing triangles. One is going to be using the formula. Sorry about that. Woohoo! I think I'm allergic to ending these videos. Woohoo! Math on. Next video, we're going to keep doing more and more slopes. Yay, slopes! Woohoo! Okay, guys. Math on, guys. Math on.